systems in an environment that contains 25,000 plus managed Windows devices. Okay. So everybody knows today the bad guys go after the end user, and securing the end user desktops in an environment my size is a big task. It requires a lot of resources to go out and do the patching, to do the vulnerability remediation, do those types of things. We've been looking for different ways to try to cut down on that, to reduce the amount of work we have to put into that. What I'm going to talk about today is one of the ways that one approach that we're going about to do that. So before I get started doing that, just a couple of things. I mean, the internet's everywhere. Everybody's connected to it. It's getting bigger, and everybody connects to some sort of commercial piece of hardware, commercial piece of software. What the public doesn't know anything about vulnerabilities, don't care. InfoSec awareness, even in the industry, is not as high as it should be at this point. If you're outside of defense, healthcare, or financial. Unfortunately, IT has developed, unlike 30 years ago when I first started in this business, IT is driven by the consumer now. When I first started, IT was driven by large businesses, it was driven by the government, now it's driven by consumers. So basically we end up with products with, there's no penetration resistance to the product, there's no security engineering that goes into the product, and there's very little incentive on the part of the people building the stuff to make it secure. So we end up with a bunch of insecure products. You combine that with your undisciplined user, and basically we have products that are full of flaws. Flaws go back to own systems, and all the things that we've been doing for the last 10 years don't do much with respect to trying to protect us in terms of protect our systems. In November of last year, a guy named Ron Ross from the NIST proposed a new theory or a new security stratagem. He called it agile defense. It's not really that new. It consists of all the things that we've already done, we've been doing in terms of compartmentalizing or segregating your assets. In other words, taking your servers, putting them behind a firewall in the data center, controlling what protocols go in and out to those servers. Target allocation of security controls. Don't put firewalls where you don't need them. That sort of thing. Limiting privilege. That's a big one for us in terms of we've had an environment where pretty much every laptop user had admin privileges. We've now squeezed that off. They're not doing that anymore. Routine reconstruction to a known secure state is one thing that is fairly new with us. It's not something we thought about up until the desktop virtualization idea came along. So that's just one of the tools we have in our kit in terms of trying to protect from that sort of stuff. There's nothing new here in terms of what the favorite attack vectors are. Internally, we've tracked attacks going back as long as 4 years. Okay, we can go back and track phishing emails and bad websites and stuff back to the same set of players going as far back as 4 years. And we probably could go back further than that if we had the data. We just don't have the data. But again, this is what they do. So you've all seen this. It's basically bad guy sends an email, user clicks on email, machine gets whacked. Bad guy comes in, spreads around, and then data starts going out of the environment. Okay, so that's relatively benign. We've seen that a lot. There is a new one that we have been seeing here lately. We call it man in the mailbox. Basically, it takes advantage of a trusted relationship between an existing supplier we have and our buyers. So that relationship exists. So buyer needs something, he sends a note to the supplier, says, hey, I need a new component, I need a new widget. Supplier sends back a quote or whatever. Bad guy gets into supplier system because the suppliers aren't as diligent about what they're doing from a security perspective as we are. Okay, they don't have the staff, they don't have the budget that we have in order to try to protect our systems. The bad guys know this, so they attack the suppliers. They compromise the supplier system. Once he's in the supplier system, he basically becomes the supplier from a masquerading perspective, fishes around inside the supplier's mailbox and finds out, well, we've requested something from this particular supplier. He takes that thing that the supplier has sent us and adds a couple of extra things to it and sends it back. Now, the buyer, who works with the supplier on and off all the time, doesn't suspect anything because it's just an updated quote. It's an updated revised spec, whatever it happens to be. And the next thing you know, we got the bad guy in our system. Okay. Targeting websites, again, nothing new here. We call them water holes because it's where people gather. Same attack vector. It's a different attack vector, but the end result is essentially the same, right? We get machines that are impacted and bad guys in the system. We did actually have a USB-based attack run against us at one point in time, about 3 years ago. You're all familiar with USB-based attacks. Essentially, it works if you had auto run running, which at the time we did have auto run running. So, we get bad USB drive. Literally, they seeded the parking lot. Okay, we had 10 drives that actually made it into the facility. 6 of them actually got plugged into machines. Yeah. Okay. So the USB drive comes in, gets into the machine. It's viral in nature, so a good USB drive goes in the machine. It gets now bad, and it just jumps from machine to machine to machine across air gaps into somebody's laptop that goes into their home system. And they plug in a new USB drive. It's now bad. But the end result is data goes out the door. Okay. Lately, we've seen a new one. It's similar to the man in the mailbox type thing, in the sense that the bad guy will somehow, in some way, shape, or form, either through man in the mailbox or some other mechanism, will actually get in and own one of our machines. When he does that, he installs a piece of software that we refer to as a controller. All right. Once the controller is installed, an individual will come along and plug in another USB drive. Well, that USB drive gets a collector installed on it. So now we have a USB drive floating around our environment that has collector software installed on it. That USB drive will make the rounds through the facility, being plugged into machines, and every time it's plugged into a new machine, again, if the auto-run feature is working on the machine, it installs a little piece of software on there that starts plowing through the machine looking for specific things. Okay, there's an INI file that goes with the software that tells the software specifically what to look for. In our case, if it's one of our airplane programs or something of that nature, it starts looking for that software. As it finds the software, it collects it up, it zips it up, and then encrypts it. Sooner or later, that controller or that collector USB stick will come back around to that machine. When it does, the collector then just dumps everything that's gathered up back onto the USB drive. Okay? The USB drive eventually will get back to the machine that installed the original controller. When it gets back to the original controller machine, it dumps everything back onto the controller machine, and the controller machine ships it off to the bad guys. Okay? So these are the kinds of things that we're dealing with in our environment today. All right? So that's a little bit of history. Motivation, why do we decide we're going to mess around with a virtual desktop infrastructure? My boss asked me about it, and I said, well, look, let's look at virtualization. Let's go back to this whole concept of centralized processing, which is where we started out 30 years ago. We'd had a significant amount of success with presentation virtualization using Citrix Presentation Server to virtualize our factory floor, in the sense that we were able to go in and eliminate all the blueprint booths in a mile-long factory floor and go to a delivering work instructions and delivering blueprints virtually through a Citrix Presentation Server. So we figured, okay, if we can do that there, it shouldn't be that difficult to go off and do this whole server-based virtualization stuff. Obviously, the biggest deal is to enhance security, and this is where we feel like there's the biggest benefit. If you go into a fat client environment, every disk, each machine has its own disk with its own set of operating systems and its own set of applications. That's a machine that needs to be updated and patched. In an environment where you have 25,000 plus devices, that takes a long time to get a set of patches out and rolled into the machines. So there is, between Microsoft Patch Tuesday and the time we get all the machines patched, there's a lag time there where we have systems exposed. We have a common set of applications that it goes on every machine, but there are situations where some of the users need a different set of applications. They're a one-off set of applications. Some of those applications, believe it or not, you have to have admin privileges in order to be able to run the application, or they have to have admin privileges to be able to install the application. Again, you have a user with admin privileges, the threat level on your system goes up exponentially. We also have other pieces of software, system-level software running on the machines in order to do things like full disk encryption and to be able to back up the desktops and to prevent loss of information. Well, sure.
Are you going to, A, define which kind of virtualization you're talking about at some point?
Yeah.
And B, define your scope within your environment. It sounds like you're aiming towards only desktops. Is that correct?
In this particular, for what we're doing here is just desktops. Our server infrastructure has been virtualized for a couple years now.
But you're not looking at mobile at all?
We'll get to that. Yeah, I'll talk a little bit to mobile in just a minute. Mobile turns out to be one of the issues that you have with virtual desktop infrastructure. Okay, how do you deal with the mobile guy, right? Okay, well, and I'll get to that just in a bit. And what was your first question? I'm sorry.
Defining what kind of virtualization.
Okay, yeah. Our presentation virtualization was basically Citrix presentation server. Okay, what we're talking about here is server-based virtualization, where it's server-based desktop virtualization. Yeah, like I said, we'll get to that. So in our virtual desktop infrastructure, in that environment, we basically have a single image that we maintain. So by maintaining a single image that gets streamed into the desktop, then we've eliminated the number of machines we have to remediate in terms of patching and so on and so forth. It also allows us to eliminate some of the one-off configurations that we've been dealing with. What leaves us with one image to patch. The OS patches go into a single instance, and then that instance actually gets streamed out to each of the virtual machines every time they reboot. We force the machines to reboot once a day. So, at the application level, in terms of dealing with applications, we've moved into application virtualization so that to stream the additional applications out to that people need out to their desktops. In other words, so the core application, the core virtual image will have Microsoft products on it, basically the Microsoft Office products on it, and some system-level software like virus management, those types of things. Everything else gets streamed out to the box as a virtual application. We do this using a tool called ThinApp. One thing about stuff you virtualize within ThinApp is it runs in user mode. Okay, it doesn't require enhanced privileges to run anything inside of a ThinApp virtualized application. Because we virtualize the application and stream just the application out to the user when they require its use, we can patch just that one application, and the next time the user goes to use the application, he's got the patched application. So in the morning, he could have a vulnerable version of Adobe. We get the patch, we patch it, he fires up Adobe again in the afternoon, and he's got a patched version. Reduce costs. Whether or not you reduce the cost here or not depends on how many of these things you deploy. If you're a small shop, if you've got, you're not going to see a huge amount of reduced costs. In fact, this will probably cost you more money to operate this way. In our environment, to refresh a fat client takes about 8 hours because of all the data, configuration settings, and whatnot that the users keep on their desktop. So we have to transfer all that data up to a server and then transfer it back down onto the new machine. With the thin client, refresh takes about 3 minutes. You come in with a new client, you unplug the old one, you plug the new one in. They can be in the middle of a session, doesn't make any difference. You unplug the box, hook up the new box, they go right back into the existing session.
Generally, when you refresh a system, you're doing so because there's something that you need to get rid of on the old system. What you just described doesn't actually get rid of any of their state. So is it really an apples-to-apples comparison? Well,
in our instance, when we refresh a system, it's when you when you refresh a VDS box, it's primarily because it's broke. Okay. We've been using these virtual terminals now for, we've had some of them that we've used for as long as 8 years in our presentation virtualization scenario. So, yeah, I mean, when we replace the thing, it's primarily just because we've got to get rid of it. You know, it's broke, and so we throw it out. Or we're installing maybe a new wireless client or something like that in it, and we'll pull the old client out, toss it away, and put a new one in. So. We also tend to see a more consistent performance and reliability since the machines are all diskless with the gold image streamed to them. They always start up in an optimal state, so you eliminate all your registry clutter and file clutter that essentially would have a tendency to slow a system down over time. You also eliminate any the degradation associated with the DLL dependencies because you're not loading any new DLLs. Okay, when you run the virtualized apps, the DLLs associated with the virtualized apps stay within the virtualization sandbox. They don't go into the operating system. As far as grain, I mean, this is a big deal to some of the folks. Is are we really going to do anything with respect to reducing our energy costs? Fewer desktops reduce our power requirements. The thin clients are much more energy efficient than the desktops. We figure they consume about 90% less energy than a regular desktop. In our studies we've done, we get to the best energy efficiency out of 2 ESX servers when we get to about 200 users per server, or 100 users on each server. That improves gradually, and we hit a plateau at about 1,000 users, at which point in time we figure we're saving about 73% of the energy that we would normally be spending if we were doing fat client desktops. Over 4 years, that turns out to be about 23% savings. If you throw in the air conditioning costs in the data center, it actually moves up to 43%. So, all right, pardon? Okay. So we started this out in 2006. We did an analysis of our existing setup and decided whether or not we could try to use the Citrix desktop environment to replace the various user groups. We looked primarily at task workers and knowledge workers. We also looked at high-end graphics users, but because of the requirements for multimedia and audio, 3D types things, we basically said we can't deal with the high-end graphics user at this point. Citrix turned out to be the best solution at that point in time, but neither the Citrix or any of the other server-based computing solutions we looked at would deal with all of our multimedia requirements, nor would they deal with the collaboration tool we were looking at the time. So even given those types of things, we decided we'd go ahead and evaluate Citrix as a potential solution. During that same time, a small company called Provision Networks, which now belongs to Quest, started pushing forward the idea of going to a virtual machine-based virtualization solution. And we looked at that, and at the time it looked like a good idea, but it wasn't where we wanted to be. In 2007, the first generation of products came out from VMware, Citrix Desktop Server version 1, and VMware released their first version of View. They just weren't any good. They didn't work. Even Citrix said, "This is not, here's a product, but it's not going to be what you're looking for." So we kept at it. 2008, we got the second generation of topics of products. Citrix Zen Desktop 2 came out. We looked at it. It wasn't actually, quite frankly, didn't do much better than what we were doing, what we could do with Provision Network stuff, but it was a major improvement. It was also the point in time when we could actually run everything from a single image, which was very important for what we were trying to do. In the fall of 2008, the Citrix Zen Desktop 2.1, we implemented that. That's where we learned that the Citrix Zen Server hypervisor had some stability issues and some limitations, and we decided we would just go ahead and go with ESX at the time. We were also at this point working very closely with Wise. in the development of their TCX protocol, which was going to be necessary to do multimedia redirection and USB redirection. So, in 2009, we felt comfortable enough to turn this thing loose on the general population. So we established a pilot using a hybrid approach that consisted of using the VMware ESX hypervisor, Citrix Zen Desktop 3, Citrix Provision Server to stream the OS, VMware ThinApp to do the application virtualization. We're using a Wise V10L device as the thin client, and then Wise's TCX from protocol for USB and multimedia redirection. So, from a hypervisor perspective, we're again running V3 version 3.5 on a DL585 G5 as a four quad-core processors, 128 gig of RAM. Basically, the biggest box we can get our hands on to run as a hypervisor. To deal with all the desktop management for OS streaming, Citrix Zen Desktop version 3 running on a DL385 G5 to deal with that particular piece of the solution. To deal with the desktop delivery controller, which was the piece that managed the assignment and power management for the virtual machines. It was also what was responsible for booting the virtual machines and getting them built and shutting them down when the users logged out.
At what levels did you run into problems?
All levels. I'm serious. Again, this is a 3-year. What's it? 2009. This is 4 years. This is a 3 or 4 year adventure to get through this stuff. Every time.
Problems with hardware? Did you run problems with the specific pieces of software?
No, it's always software integration. It was always a software integration effort. Trying to take the bits and pieces of software, put them together. One of the things we found in this particular environment, because it was so complex, the vendors don't know what their stuff does.
What?
Serious. The vendors do not know what their hardware, what their software does.
Explain.
Well, it just various cases of we would bring their tech services people in, have a scenario set up, and the guy would say, okay, it'll do this, and this, and it didn't. It did this, and this. Okay, so it was a constant wrangling with the vendors over what their products would do and what they didn't do. A lot of discovery on our part. Again, you couldn't believe the documentation you were reading. Again, it would.
The integration between the two different companies, like between Zen and that caused you those issues, or was it inside the one guy's product?
Both.
Oh,
it was all over. Yeah, we were basically doing a lot of work all over the place. It was no one particular thing. The one area that we did have a lot of success in, though, was with the protocols. ICA is fairly well established. It's been out there for a long time, good for doing KVM kinds of things, except streaming video. Okay, you can't stream video from a virtual machine, take some flash running in that virtual machine, and then stream it over ICA into the thin client. That's where Wise stepped up with TCX, which allowed us to do multimedia redirection. So instead of the video being streamed across the Wise protocol or across the ICA protocol, the Wise little piece of code running on the box grabbed the video and piped it over to the client using a different protocol and actually rendered the video on the thin client as opposed to trying to render it in the virtual machine.
So what do you care? I mean, you're a business. You don't care if they're watching Flash. I mean, why should
Yeah, we do, because we do a lot of training stuff. All of our training stuff is Flash-based. Okay. Yeah. So, and again, on our shop floor, keep in mind, we eliminated all of the paper and stuff on the shop floor. The guys don't have any manuals out there on the shop floor. Okay, so when a guy gets ready to go do a job, if he hasn't done that job in 3 or 4 days or 3 or 4 weeks, and he wants to brush up real quick before he goes in it, because we're talking about guys that are handling carbon-based or carbon fiber-based composite things, and if you drill a hole in the wrong spot, you're not going to patch it. Okay, you throw the thing out and you start over. Okay? So the guy wants to be sure he's going to do the right job. He's going to go in and pull up a video-based training simulator, video-based training, watch it, and then go over and get the job done. So. Yeah.
You said this was for mostly your knowledge worker computers?
Right.
What percentage of that, of your total was that?
Across all of our sites, knowledge workers probably would be somewhere in the neighborhood of about 10,000 people.
Okay.
We at the facility we have a greater than one machine to one person ratio in our environment. Across our environment, you're looking at roughly 15,000 people. So the knowledge task workers combined would be somewhere in the neighborhood of about 10,000 people. Okay, the rest of it's factory, out in the factory. So, yeah. Yeah.
I was just going to ask, before you move away from this, you said the WISE allows redirection of protocols like Flash over to the thin client.
Right.
Is it also that actually thing? So then how fat is the thin client actually getting if it's also doing all this multimedia processing?
What should do next? Do you have the
Well, yeah, it's. Let's see. The thin client's a V10L. It has. I'm trying to think. The footprint for the V10L, I believe, and the ThinOS operating system that runs on it is only about. I think it's like 120 meg. And again, that's burned into the firmware on the box, and then we can flash update that as we need to. So. All right, so back to the application virtualization we picked VMware ThinApp because it could do some things that you can't do in using the Microsoft application virtualization tools. For instance, ThinApp right now is the only one that you can actually run an application that requires admin privileges but run it in user mode inside the virtualized box. You're not required to have admin privileges to run a ThinApp wrapped application, even if the application requires admin privileges. Let's see. All right, storage again. There is a significant storage requirement for this thing because you are storing your not so much for your virtual machines, but again for your any application that you virtualize, as well as your each of the thin clients, each of your users' application profiles. So this is kind of an eye chart. It's probably a cruel thing to do, especially after last night. So essentially, you got three things going on here. Over in the green box, essentially, it goes through the process whereby the client comes in, boots up the WISE. The user comes in, boots up the WISE terminal. It comes up to a login prompt for the terminal itself. User logs in with their AD credentials. They're validated. Let's see if I can go up here. Where's my cursor? It's not going up there. They would be validated against the Active Directory. Once they're validated against the Active Directory, then they connect to the Citrix Desktop Delivery Controller, which then connects up to validates all the licensing on any of the applications that they're authorized to use. Ultimately connects back to the ESX host and requests a virtual machine. Once it's requested a virtual machine, you jump over into the yellow box where the VM then Pixie boots over to pulls up his boot image. The boot image is streamed to the box. As soon as there's enough of the image streamed to the box for it to actually start displaying back to the user, it starts to display back to the user. At that point in time, you jump down to the white box where the profile manager steps in and delivers all of the user-specific profile pieces. So you have 30 seconds.
Nice.
Yeah, it's faster than the laptop boots. And of course, now saying that for our company laptops is not saying anything because it takes 8 to 10 minutes for one of our company laptops to boot because of all the crap that's on it. But this will boot. Yeah, this boots up in about.
How much optimization did you have to do to get it back to that point?
A lot. Yeah, there was a lot of tuning of the servers, a lot of tuning of the software parameters. But again, it's pretty consistent. You can consistently, punch the button on the box, boot, reboot, and.
How, considering that you've put a lot of work into building this pretty cool infrastructure, but if you hadn't, you would have the standard local machines and people ripping their hair out in frustration.
Right.
Do you think that the trade-off of manpower and womanpower, forgive me, is better the way you've done it, or worse, or do you know what I'm saying?
Yeah. This infrastructure, again, the pilot was we piloted 60 people. We actually were forced into putting it into a production mode as a result of a contract win where they came in and told us we had 60 days to facilitate 2 remote sites, and it was 60 days starting 3 weeks ago. Okay, so we were stuck with having to bring up a couple of sites. We actually were able to bring them up in this infrastructure and meet our contract deadline and not lose money as a result of that. But I'll get to you in just a minute. Okay. But your original question about, is this better or worse? From a security operations perspective, with respect to what the security ops guys have to do in terms of vulnerability remediation, they love this whole concept, because every spinning disk that I take out of the environment is one less disk they have to go mess with in the event there is a problem. Okay, so yeah. Well, hang on, let me get this cover here.
I was just wondering how you've changed how you do backups, because it seems like you now have a huge single point of failure as far as
The infrastructure is all redundant. Okay, so basically we have multiple in the pilot infrastructure. That's one of the things we checked in the pilot infrastructure is redundancy. How do we make this thing redundant? Because yes, you're right. This thing relies heavily on your network. If your network goes down, people don't get to work. Okay, it relies heavily on your data center. Right, you lose your data center, smoking hole disaster. People are not going to work. So yeah, we basically built a lot of redundancy in this. So essentially, this entire infrastructure is actually spread between 2 data centers that were 3 miles apart. Okay, so even though stuff we use the NetApp storage, so we were using the NetApp replication tools to be able to basically snap images across and put them in the other data center. We actually failed it over, so we failed from one data center to the other just to make sure that we could actually do it. With respect to backups, the user's data is still out on their home directories that we provide them. Okay, the only additional thing we had to worry about backing up was the profile information. It's stored in a separate set of storage, and so their normal data is backed up using the typical tape backup, snapshot, that sort of stuff. Their profile information, which was on a different storage array, was then stored over and replicated over to an offsite storage area. Yeah.
How has this new setup impacted your response metrics?
Well, since it's such a small window right now, it's of just 60 people essentially in the pilot. I don't know that it has at this point. Again, the idea behind what we've been doing is we haven't noticed any of the thin clients have not showed up anywhere in any of the incident reports, and primarily because most of the people who are actually using them we've got some guys out of our engineering organization that we work with on a pretty regular basis from an IT perspective, and then a lot of the guys on the pilot were just IT guys, so guys that typically are a little bit more aware from a security perspective. Yeah.
what's the load that's put on both your local network and your WAN network?
Local network, it's not much of a load. It's ICA, so 75 to 150 kilobits per user. And then when you throw the TCX stuff in there, it jumps up a little bit, but not much. Not enough to notice. Not enough that we decided we need to put this behind any kind of a QoS type solution. So, and then from the WAN perspective, I actually used this system while I was here. Okay, I've got a this thin client laptop, 1 gig of flash drive, 1 gig of RAM in it, wireless and all that jazz, and I can actually log into our wireless infrastructure, or into this infrastructure with this box from pretty much anywhere I can get a wireless signal, and then work in that environment. It depends, on a wireless connection, a choppy network, you'll notice it. It's not, remotely, it's not as the response is not as quick as doing. Being on the campus where all the hardware is at, but it's usable. It's very usable. So. Okay.
I'm sorry, you said that your ICA bandwidth was 75. What was it? 75 to 100 or so kilobits per second.
Mm-hmm.
What is your resolutions and screens?
I run mine on a 24-inch display, 1920 by 10, whatever. Yeah, 1200 some. Big. But again. the video processing is done in the thin client, right? So, you're not pulling that much across the screen, across the wire.
I see, but you're not doing flash there. Okay.
No. Again, the flash is the ICA protocol. The flash, all of the stuff that's flash related and USB redirect type things are done on a separate protocol. That's the TCX protocol that is proprietary to WISE, and there's a component in the virtual machine that grabs that stuff, strips it out, and sends it via a different protocol to the actual thin client itself. The thin client then renders that video. Okay, yeah.
So it's encapsulated in a sense?
Yeah. So,
I'm sorry.
no problem.
But when you do the video,
I like this better anyway.
No, but when you do the video, then what is your bandwidth go there?
Again, depending on what it is, it can be a couple hundred K. It's not that bad.
Doesn't
Again.
go over a megabit or so?
No. So yeah.
Can I ask that you repeat the question?
Pardon? I'm sorry. Yeah, I should be doing that. Sorry. For the audience out there as well. Where did we leave off? What box were we in?
Just go to the next slide.
Yeah. Okay. Okay. So what have we learned so far? Well, we talked protocol is critical. We've talked a lot about the protocol. ICA is probably the most mature protocol on the market for doing this thing and does the best job. We did work with RDP for a while, and it just doesn't cut the mustard. Multimedia redirection is and USB redirection. You got to have these two things. If you don't, again, you can't run flash video. Users get really upset when they can't plug a USB drive into the thin client seat on their virtual desktop. So you've got to be able to do USB redirection. Those two things came via TCX. Printer driver management is a problem. If you've ever done anything with a Citrix environment, a Citrix presentation environment, you got a guy who wants to plug his printer in or wants to print to a printer. There is no universal print driver, and so that's one of the things we've learned is that printer drivers, dealing with printer drivers is going to be a problem, as well as offloading. Again, offloading the video processing. So.
It's a paperless office, not printers.
Yeah, unfortunately, you can't claim a paperless office. That doesn't work. Yeah.
Can you touch on that real quick? How does the hardware doing all this virtualization attach to local utilities like a printer? And the printer's got to be in his office.
That's the USB redirection. That's the TCX protocol. So yeah. I can take again this box here, be wired up or be hooked up through our portal that we go through in order to get into the environment. Plug a USB drive in here, and it shows up on my desktop in my in virtual.
Not necessarily connected to the computer; it's connected to the local network, right?
That depends. If it's a local network printer, then the virtual machines can see all the network printers.
So you would say he would see maybe many printers.
Right. Yeah, he'll see every printer that's attached to whatever print servers you have out there. Now, it's the local printer that's the issue. And in our environment, management staff is required to have a local printer in their office to do printing of personnel type stuff. They're not allowed to print that on the network printer and then run out and try to grab it before the next guy gets it, right? So we have to solve that printer problem in order to be able for this environment to work. Running separate images is cost prohibitive. We run a single image. If you get into, now you could probably run 2 or 3 different images, or you could run 2 or 3 different operating system images if you chose to, but you can't run a separate image for every individual you have in the company. I mean, you might as well go back to a regular fat client, right? There's no point in doing that. So you have to get down to a single image. If you're going to use a single image, you have to do application virtualization, because not every user has to have every application. Licensing would kill you if you put every application into that image and then stream that image out. Plus, that image starts getting rather big, and it takes longer for the client to boot up. So, there are application virtualization integration issues. You have to think about what it is you're going to do when you do the application virtualization. If the application has a lot of hooks into other applications, you have to virtualize the package. You cannot just take the single individual application. One example is I use a tool called OneNote. I had them virtualize OneNote separate from my regular desktop, and OneNote runs fine, but it doesn't know anything about the fact that Microsoft Office is there, so I can't use any of the integration between the two. Okay. Somebody asked about the hypervisor or the mobile user. You can't support a mobile user in this environment. Okay, so when I get on, if this is the only machine that I have, when I get on the airplane, I can't do anything with this machine until I get to where I can get to a network and get back into the environment. All right, there's no way to support a mobile user at this point in time. Data center impacts. Okay, you deploy this in a big way, you are going to impact your data center. You're going to put more servers in the data center, which means more electricity, more cooling, more storage, all those types of things. So those are things that have to be taken into account when you go in. What's next for us? We are going to spend this year looking at VMware View 4 and Zen Desktop 4. We're working with a couple of the other business areas. They're rolling out big pilots of this stuff. We're just going to kind of scam onto what they're doing to see how well it's working for them. PC over IP is a new protocol. It's based on some work that's done by a company called Teradici. What I've seen so far in the labs and stuff is pretty impressive. However, the problem with Teradici early on was it was like a one-to-one relationship. You had to have one piece of hardware in your client and one piece of hardware in your server, and those two could talk to one another, but that was it. They've now got to the point where they actually have a software client that will run against hardware, and you can have a many-to-one relationship. We'll spend some time looking at that. If it works, then it eliminates the need to do the USB redirect and the video offloading, multimedia redirection goes away because they handle all that inside their protocol. Type 1 hypervisors for mobile users. This is how we're going to deal with the mobile user, or attempt to deal with the mobile user. There are a couple of Type 1 hypervisors currently available today on the market. We've spent some time looking at them, but they're I don't know. I call them pre-alpha. You can't manage them. There's some real issues with them. So we will spend some time looking at that. We have to solve the mobile issue user. We are taking our application virtualization production, our application virtualization that we did last year. We are moving it into production. We're comfortable enough with it today that we can move it into a production environment. We have a 16-bit application that runs the shop floor in one of our other locations in California. We can't get rid of it for 2 more years. Typically, 16-bit applications don't like to play inside Vista. That's the environment they're moving to. We've been able to take this commercial tool, take the commercial application, wrap it inside of ThinApp, and deploy it out to 1,600 desktops with no problems. Runs in that environment. Yes, sir.
From the time that you get a request to put a new application online, to the time that it's actually delivered, something like Google Earth, let's say you get a request from Google Earth, it's approved. How long does it from the time that you start to the time that you can actually deploy on that?
Depends on the application, depends on how the consultants answer, right? Depends on the application, depends on how integrated it is with other things. So Adobe, for instance, Adobe Reader, which doesn't really integrate with a whole lot of other things, we can take a brand new version of Adobe from the point in time we get it to the point in time we can start rolling it out. It's about 4 hours. Okay, and that just depends on how busy the guys in the image lab are. Okay. And we've had to do that on numerous occasions, obviously, with all of the patches that have been released for Adobe. It was an interesting thing that I meant to mention earlier with Adobe, and I took a patched version of Adobe and gave it to the forensics guys and said, I want you to run every piece of malware that you have, a PDF-based malware that would whack an Adobe user.
Are they done yet?
Yeah, they finished with everything we had, okay? But basically, we ran all this stuff in inside of a virtualized Adobe application. The net effect is that every time you ran a piece of malware that was bad, it did blow up the virtualized application, but none of it leaked into the operating system. So there were no hooks set in the operating system, none of that stuff. So it is at least with Adobe, it's a good way to know that you've got a piece of malware because Adobe blows up, but you also have protected the operating system and the machine itself. None of the badness leaches out into the machine. So, yeah. Okay. And finally, we also are going to spend some time looking at remote desktop services for Windows 2008. There's a lot of stuff that's been put in here that we were interested in looking at in terms of it's the stuff that we've had to do third-party applications for and that kind of stuff to bolt onto the existing infrastructure in order to be able to do some of the stuff we need to do. A lot of that stuff has showed up in 2008 R2. It may appear to be sort of a step backwards because that is a presentation virtualization versus a desktop virtualization scheme. I don't know. We'll take a look at it, see what happens with that. Okay. People have had any other questions? Yeah.
Two questions. First, can you repeat my question?
All right. I'll repeat your question. Thank you for reminding me. Yeah.
Second question, which were the type 1 hypervisors that you looked at?
We haven't looked at it. The only we've looked at. What are the type 1 hypervisors that we've looked at? To say true, I don't recall the names because we haven't actually started doing any work with them. I just know that there are two of them out there. So if you go Google Type 1 hypervisor for laptop or desktop, they'll pop up. I just don't remember the names off the top of my head. Yes, sir.
You said that RDP you looked at, and what were the problems with it that you faced?
Pardon?
What weren't the problems?
Oh, yeah. Well, so the question is, what were the problems with RDP when we looked at RDP? It's just it doesn't do as well in terms of the video piece, and it's chattier than ICA in terms of how much has to go back and forth between the machines, and it just wasn't as efficient as ICA was with respect to moving keyboard, video, mouse. Yeah. So. Yes.
Have you found that incident detection is easier with virtualization?
The question is, have we found this incident detection being easier? Define what you mean by incident detection. So we're talking about the same thing.
Well, in terms of finding if intrusion attempts.
Well, like I said, since we have such a small footprint with this stuff, I don't have an answer because we haven't noticed anything specific in the 60 or so users that we've got, or 120 or so users that we've deployed so far. So we're running the same tools in this environment, with the exception of desktop backup and full disk encryption that we would normally run on any of our other laptops. In other words, the IPS, the IDS, the firewall, all that stuff is still running in that environment. As far as I know, we haven't had anybody try to actually attack that particular environment. So, how am I doing on time? Oh, 10:52. Okay, go ahead.
What has been the cost of Citrix? Because I know Citrix can add up quite a bit with licensing and everything. So how does that scale with doing fat clients versus benefits?
I hate to talk cost because of the fact that who I work for and how big we are. We don't, we get numbers different than most other people do. But if you add the whole thing up, we've got to get to the point where we're deploying. Over the last 6 years, we spent around $600,000, maybe close to $750,000 in just doing this work. Okay, if you put the whole thing together, when we do the ROI and all that stuff, we've got to get to the point where we've got to deploy this out to about 2,500 desktops before it starts making money or before it starts actually saving us a lot of money to make it worthwhile.
From 60 to how many?
We're going to scale from if we get my way about it, we'll scale from 60 to about 10,000. Yeah, and that's just in my business area. Other business areas are watching real close what we're doing. So ultimately, this could scale from scale up to 100,000 plus.
Awesome.
Yeah. So, about 7 more minutes. Any other questions? Yes.
Thinking back to the beginning of your presentation, you're describing some of the attacks that you're seeing.
Mm-hmm.
This might feed back into the incident question where, with a population of 60, you might not be able to say, but as you scale this up, how are you picturing that this is going to help address that problem that you described with the USB drive migrating around and collecting data?
In that particular instance, I'm sorry. I was waiting for one of those. I haven't got one all day. Anyway, now I got to remember the question. The question was how do we anticipate this is going to impact our the number of instances we see, or incident response type thing if we deploy this with respect to the USB things. One of the things about the way this is deployed is that even if somebody does come in and somehow, say a guy walks in with a USB drive, plugs it into one of the thin clients, it infects that particular image. When he logs off, that image is blown away. So anything that goes with any changes that were made to that particular image are gone now. They're flushed, and when he logs back in, he gets a brand new image. Okay. So that's the real draw. There is the idea is that look, we're gonna start basically resetting the machines back to a known good state at least once every 24 hours. Okay. So your exposure is if you've got 24 hours, if you've got a bug, you've got the bug for 24 hours.
Didn't you have some sort of data persistence related to profiles? You said.
Yes, there is. It's user profile. It's things like bookmarks. It's all the things about you in a Windows environment that make the machine know you're you. That's unique to you.
Cookies?
No cookies.
JavaScript? Anything?
No, none of that kind of stuff.
Okay.
Yeah.
What about files like documents, folders?
Those go off on their normal storage. Okay, so they'll in our environment we basically have a desktop. We have a U drive. It's a home directory, and that's where all the data storage is done is on the home directory. They're not allowed to store anything in the image because we blow the image up.
Also, what about things that can live in those documents?
Well, again, I can't. That's not the problem I'm trying to solve. Okay. You run. The question is, what about things that could live in the documents? Again, we're still running antivirus, right? We're still doing all the normal basic blocking and tackling things that you do on any normal desktop. So if if a 0 day is going to slip through, it's going to slip through. Okay, that's not the problem I was trying to solve.
But you're still centralized on your antivirus. You're centralized.
Yeah, all of the normal enterprise tools. The question, the comment was, we're still centralized. Yes, all of our normal enterprise tools are still centralized. We're still running a centralized everything with respect to maintaining that desktop.
You don't have a client running around with 5-month-old definitions.
Right. Yeah, exactly. Everybody's virus definitions are up to date, just like a normal fat client setup. All right. Anyway. Thank you. And that's me if you need to get a hold of me.